So, so this section shows you list of tools you can use to perform operations in this your Eagle card software. You understand? So like now, this is your net. This is used for connecting components. It's like your connection wires. So you get me?
Yeah.
You click on this. When you click on this feature, you'll be able to connect one component to the other component. As you can see here with the green line.
Okay.
Yeah. So also I'm connecting this with this. So this is the positive side of your LED, and this is the negative side of your LED.
Point the positive and negative. I'm not saying.
Okay, this is the positive. Can you get it?
Point
Or
it.
your
I'm not.
hand? Okay, can you see my um, cursor? Can you see my cursor?
No. It came up and then disappeared.
Okay, like a cross sign. Can you see it now?
I'm not saying your question.
A cross sign looks like a cross sign.
Where?
You have seen it, right?
Okay, I see it now.
Okay, that one, I've
It's
seen
not.
the negative and positive. It's labeled.
Yeah. Okay, that's very good. Yeah. So this is your positive and that's the negative. So as I've said before, this is your toolbar. So you come here and pick the feature you need to perform your operation. Like this, as I said, is the net, and you use it to connect components together. It's just like your wire. So these 2 points, I'm going to be connecting them to the what? To the positive of my battery. And as you said earlier, it's already labeled the positive and the negative section of your component.
I want to ask something.
All right.
I can't see your cursor working inside the board because I just see the stuff connecting. So you
Okay, you
click
just
on
click
the
on it.
tool? Yes, I just see it connected. I don't see your cursor clicking
Wow.
on where you want how to connect. So I don't understand how you get to it.
Okay. I don't know. But you are
Like the
Um,
saying
cursor
you my
work
cursor.
sorry, is
only outside.
sorry, I want to ask a
Okay.
question. Is it possible to record from any of your end?
I don't think I have. Okay, to record the video, right?
Yes.
Let me check. Okay, sorry, I'm coming. Okay, I'm not really sure if I can record from my end here.
Okay, I'm using a screen recorder here, actually.
Okay, I'm using a screen recorder. All right.
Yes.
Okay. Okay, I
Alright.
think you should share the video after the meeting.
Yes. I'll send you the
Oh,
video, Oluchi.
Alright, that'll
Mm,
be better.
okay. So you can
okay.
continue with the explanation.
Okay, let me continue with this. All right. So now I want to rotate this component. What I'll just come here is to pick a feature that I want to use for rotation. Just click on the feature, then come to your component that you want to rotate and just click on it. So sometimes you may want to locate the origin point of this component for um, the future can perform any operation on it. Like now, for this label AB94, this is the origin point of this label. So if you just click on this, you just be rotating the label.
Which
You will not be
label? Okay, AB9V.
AB9V, yeah.
Okay.
You just be rotating the label instead of the main component. Like now, this component, this is the battery source, right? So here is the positive terminal and here is the negative terminal. So, but this point here shows the origin. There is a plus sign in the middle of the schematic. Can you see it?
There's a plus sign in the middle of the schematic.
Yeah. Can
I
you see
can't
it?
see. I can only see the plus sign and minus sign in the AB9V.
Okay. Then you can view the middle of the component. The middle.
Can't see.
The middle. Okay. Just bring it. I'll bring it up. Okay. Can you see the plus sign now?
In the middle of the component.
Okay, as I'm zooming in, can you see me zooming in?
No,
The component is not zooming. Okay,
no, it's not zooming.
I think something
okay,
is wrong with
all
my
right.
end.
Okay, let me just assume. Okay, sir, but you can see what I'm doing.
Yes, I can see it.
Okay, sorry. I can see now. I've
Okay.
seen it. Sorry,
Okay,
I zoomed my own screen, so I was not seeing this part.
okay. Now you get the positive at the middle, right? The
Yes.
plus sign at the middle, right?
Yeah.
Okay. So now you can actually click on it to perform the operation of what? Rotating the component. You understand?
Okay.
So any operation you want to perform, you come to your tool bar and check for what you need. Even if it's to delete the component, you can come here and click on the delete. Then you find the origin of the component. Click on the origin.
Okay.
Yes. So here I want to just rotate the component. That's when I clicked on rotate. Then
Mm-hmm.
here you click on the component until you rotate to the direction you really want. Really need.
Mm.
So now you go back to the toolbar and click on next, then also continue your routing on your schematics. Now, if you notice that we actually have a very simple circuit consisting of two LED, two resistors, and your battery.
Yeah.
So if for someone who is very conversant with electronics, you might want to be asking the ratings of all these components, do they really matter? So for a software like Pro Tools, if you want to simulate what you can be thinking of the rating of the components you need. But since in this our case, we are just talking about the design consideration of how our PCB will look like. That is the parts that we're going to be making use of, the size of the parts. So if your PCB can give you the design you need, yeah. So the rating of your battery, maybe like 9 volt battery, it really doesn't matter. Can you get? Do you relate with what I'm trying to say?
I'm trying to understand. If my PCB can do well, I don't need to read.
So let me say what I've said before. Like now, this is a resistor.
Mm.
So usually you want to be using 220 volts resistor in your
Yeah.
you get so that to just prevent this LED from being damaged by over voltage from the battery
Mm.
source. Yeah. Why this battery source? You might want to be converting the value of this battery as maybe 5 volts to also
Mm. 5 ohms.
turn
Yeah.
on this LED. Yeah. But since we are talking about the PCB aspect, we are most concerned about the PCB aspect. How to design the PCB board, you understand?
Okay, so we don't need values for
So
now.
exactly, we don't really need those values. All we just care about is the size of our parts. Do they really um do they really give us what we need in our design? So that's just
Mm.
the consideration we're thinking of here. So can you
Okay.
get so we are done with this connection. It's a very simple circuit. So I don't know if maybe we'll maybe having another section here. Maybe I can come up with something better. So at this top menu, you'll be seeing some options like your save, print. So here you'll be seeing generate stroke switch to board, where you'll be seeing the SCH and BRD.
Yes.
And if you notice,
Yeah,
the
I'm seeing
color of this board there is green.
it's green.
Yeah, it's just giving you an idea that you're actually in your schematic environment. So if you click on this, it will be taking you to your PCB.
Okay.
So this is the PCB environment that is generated.
Oh.
So you can get. So as I was
Yeah.
telling you earlier, we were just in the schematic environment. But as we were connecting all these components at the background, you understand, the
Mm.
PCB is being this thing is being generated automatically.
Okay.
Can you get me?
Yes.
So now, if you still come back to this menu at the top, you discover it has turned to what red.
Yes.
Yeah, so it just gives you an ideology that you're actually in your PCB environment. So the first thing you will be needing to do here is to position your components from this point into your board. So this rectangle you can see here is just the region, you understand, where your component can be placed for your PCB
Okay.
to be produced. You get the idea? Now, for this free version of eGood that I'm using, this board cannot exceed this size, but there are paid versions where your size can be. So to move this your component into the board, you just go back to your tool, your toolbar, like I said earlier. You can move, you can delete, you can copy, you understand? You can perform some various operations on this. So you just come here to move. Like as I hover on the feature, you can see the name of the component coming up. You can see that. So you click on remove. Then we also, as I've said earlier, you you locate the origin of the component. That's where you'll be able to perform an operation on. If I pick anywhere, if I
Sorry,
pick
what did you
anywhere,
pick? What did you pick that you use in moving it?
yeah. So what I said earlier is you come to
Okay,
this
move.
two
I've
bar,
seen it.
two bar. You see move.
Yes.
Okay, you can see my cursor now, right?
Yeah, I can see very well.
Okay, so you just click on the move, then you come to the components you need to move. Like this is the battery.
Yeah.
Yeah. So at the center of this battery, you can see a cross, which shows
Yes.
the origin of this component. So you now drag it into your board. You can see what I've done.
Yes.
Okay. So you also do that for other components like the resistor. Click on the resistor and drop. Click on this resistor, drop, get. Then for the LED, you click on this, you drop, and you click on this, you drop. Did you get the process I just went through?
Yes. Yes. Yes.
Okay, now let me try and do some fine tuning to this circuit. Let me adjust the position of this my 5 volt battery. So I can also come to this my rotate here and pick the rotate feature. Then come here also click on the origin. Now you see it has rotated. So those wires are no more overlapping each other.
Yes.
So also for the LED, okay, I've been able to rotate these two. And let me try and rotate for this store. Yeah. So you've seen what I've done. Then also pick the move tool again, just for positioning of your component, so that when you are routing, you will not be having any issues of jumpers. So to minimize number of jumpers you may be having in circuits. So because this is actually a simple circuit, you may not have any issue with jumper. In fact, we may not need to auto route with this. So now let me try and resize this board. So what you do is to come to the same toolbar to click on your move feature, and then you click on the board, the rectangular edge, then just move it so that we minimize the space. So are you seeing what I'm doing?
Yeah, I'm seeing it.
All right. So what we'll be going next to is to perform the either auto routing or manual routing. I can even advise manual routing in this aspect because it's
So,
actually
what do you
very
mean
simple.
by manual routing and auto
So
routing?
okay, let me give a description of that. So auto routing now, if a routing in general is the process in your PCB design where you now connect the buses, or let me just use the word buses. Yeah. Okay, sorry. Give me a minute. Okay. So you connect the buses that move from one part to the other, just like we were doing in the schematic and view of this software. We were connecting the wire and the components
Okay,
using some
okay.
certain wire. So for this
Yeah.
PCB now, okay, I will try and search for an example of a PCB board so that to give a better explanation of what I'm trying to see. All right. Okay, can you see my cursor?
Yes.
Okay. Now you can see the page I have gone into.
Yeah.
Yeah. So you discover that there is a hole here and there is a hole here. Now
Yeah.
to connect this hole to this other hole, you must route.
Okay, that's what you mean routing.
So yeah, so these things are called your traces. This is your what I was calling buses earlier are your traces.
Okay.
Yes. So that's just what I'm trying to explain. Let us go back to the environment. So here you come into your at the same toolbar, you, you go to this feature that says auto router. Can you see it?
Wait, auto router. Where is the
Yeah,
cursor? Okay, I've seen it.
auto router. Yeah. So you click on this auto router. So some set of options will come out. So whether you're bored, then since we are not dealing with just two layer, we are not dealing with two layer board. We're dealing with just a single layer board. We will click this as N/A. Yeah. So that it will just be having just the bottom traces. Okay. Then here you can pick medium or high. Okay. Then continue. Then start routing. Now can you see how the board has been routed?
Yes.
Okay. Now click on end job. Usually because this is a very simple circuit, you will not be having issues with jumpers or the rest. But when the circuit becomes very complex, you might need to even perform some operations that require you to put some holes that later on you will drill and use jumper to connect those components manually. So
Oh,
now, if you notice, this your traces are not quite deep. So you could have set it in your auto routing, but now you can also perform a manual manual trace. Let me use the manual trace this thing. So you will see this route air wire.
yes.
Okay. So when you click on this route air wire, at this top bar, you'll be seeing stuff like the width of your wire, diameter, radius. But what concerns us right now is just width. So here maybe let me choose 30. Are you getting me?
Where did you choose 30 for?
Yeah, so what I said earlier, when you click route air wire, an
Yeah.
option will come up.
Come
You
up
get.
like this. Okay.
Now, can you see width, drill,
See it.
diameter, and radius, right?
Yes.
Can you see that?
I can see them.
Hello?
I can see them.
Okay. So at this your width, there is a drop down that gives you certain values, 5.9000551 and some other value. So I just picked a bigger value, you understand? But we'll be able to have a conceptualization of this value when I start routing manually, just to increase the size.
Okay.
You get. So here I click this, okay. Then sorry, you have to click your layer from top to bottom. Since it's just the bottom um, surface we are dealing with here. So then you click here. Okay, can you see can you see what I'm doing?
Yes.
Okay,
You're
so you can
clicking on
also
the
click it.
cross. The
Thank you very much. What I'm just doing is I want the trace to be kind of larger.
okay.
Can you see what I'm doing?
Yeah.
Okay, there is something I just did there. I wanted to rip up this wire because this wire and this wire, sorry, this trace and this trace are just performing the same operation. So it's not necessary to have this tiny trace here. So I want to rip it up. What do? I come to my rip up. At the
Okay.
toolbar, you
Rip
can
up.
see something
Yes.
called rip up. So that's what
Yes.
I just clicked on. Then I clicked on the trace I want to rip up. So you
Okay.
can get it. So now we have a very simple circuit design. Now, in your PCB design, you will not want to be seeing all these. Yeah, sometimes you might need to see them so that it can give you a conceptualization of where what will be where. What I mean by that is, for example, now, if you don't want to be coming back to your software to check where is this component located, like now you have the battery here, you can just leave this point. But the only issue we may have is if you want to create your PCB manually, when you are etching your board, okay, I don't know, I've not explained anything about the physical process of PCB production, but let me just use the terminology and maybe we might have a session on that later. So, but what happened is this image, this line you are seeing here that is trying to give you where this component is located might cause a short circuit between this line and this line. So we don't want to be having that thing. So what do? We come to our layer settings. Can you see the layer settings here?
Yeah, I can see.
Okay. So we click on the layer settings. So in this layer settings, you see the visible things you can get on this your board. So here we can have top. So top are identified by the red color. Since we don't even have any top here, if I turn it off, you will not get. So you can see something like an eye,
Yes.
right? So it's just trying to tell you whether the future you are clicking on or the layer you are clicking on is either being visible on your board section or if it's not visible. Okay. So like now, this bottom now, if I click it, for example, the eye is present there because it's visible. You can actually see. But when I click on it, you see it's gone. Can you see it?
Yes.
Okay, so I will click on that back. And I don't need the top layer, I'm taking it off. The pad, I need the pad because that's what I'll
Sorry,
use to
sorry,
give.
sorry. Please go back.
Okay. Which
The
part?
previous thing you did. You said that
Okay.
when you click on that button that I wrote 16, something went off. I didn't notice. I want to
Okay.
view again.
This button, if you click on this eye, I'm just saying
Mm.
the eye, but it's your view. If you click on
Mm.
it, you discover that the feature has gone.
Okay.
Yeah,
Yeah, yeah, yeah.
it's yeah, that layer has been taken off. That means it's not being visible on the board. When you are printing, you are not going to be getting that feature. Since that is the main reason why we're even doing PCB. So you click it on. You get me?
Yes.
So the pad, we need this pad because that's where we are going to be mounting our SMDs, our dual inline packages. As I've explained earlier, they are just components that you need to penetrate through your board, you understand, in order to connect them.
Okay.
Okay. So we need the pad, we need the pad. VRs, we don't have any VRs. So let me explain what a VR is. So a VR is kind of like a hole that in a multi-layer board that joins one layer of your board to the other layer of your board. Okay, I
One
don't know
layer
if
of a board.
yeah, let me try and let me go online and browse if I can get any example to show you. Okay, yeah. So I'll be doing two things. I'll be showing you how it will look like in real life and just the how will I say the cross sectional area of your multi-layer board if you are going to be having a multi-layer board. So let me just use this as an example. So if you see this O that is here, this tiny O,
Yeah.
can you see my cursor?
Yes, I can see it.
You see this tiny O, sorry for that. So this tiny O, all these are vias.
Okay.
They are vias. Now, if I should cross within this via now, if I should cut this board into two, this is what you'll be having into two cross-sectional area. So you'll be seeing one layer of your board, understand, extending to the other layer of your board. I hope it's not too complicated.
One layer of the board extending to the other layer of the board. Use cursor
Yeah,
and show me. Let me understand.
okay. So wait, let me start from where I started. Okay, let me use this as an example again. So now let's imagine you had a top layer of this form. You understand? And if you should
Yes.
turn this board over to the other side, you also be having some parts where you can connect some things. You get the idea?
Which board? I'm not
Maybe
seeing your
maybe a
cursor.
two-layer board. No, no, no. I see
Okay.
my cursor. Yeah.
Yes, I'm
So
seeing it
this
now.
preview. So imagine this was a bottom part of the board that if I should turn flip it to the other side, maybe I'll be having also traces at the other side where I can also connect components. Just this type of traces.
Mm.
Okay. So what happened is maybe as I was routing, you understand, it came to a point whereby this point on this layer had to be connected to the back layer of the board.
Okay.
So this place you are seeing now, this place, are you seeing my cursor?
Yes.
Okay. Can you see this image I'm showing you here? Where
Yes.
one, two, three. All right. So let's imagine this side I'm showing you here that my cursor is on now. It's relating to this point here, related to this
Okay.
top. Uh-huh. So now the VS is just this long line that is
Oh,
connecting
okay.
this surface to this
To the other
down surface,
surface.
bottom
Okay.
surface. Thank
So
you
it's
very
more
much.
like it's connecting the front and the back board of an
Thank
electronic
you
board.
very
All
much.
right.
Yeah. So boards get very complicated. Like you can have as much as six-layer boards board. So that is actually complicated, and this is not part of our scope for today. So, like our scope for today, we are just dealing with a single layer board. Okay. So we don't need a VR, so we can take it off. Even if you take it off, the feature is not there, so you will not see it. So also there is no unrouted, so I'm also taking it off. I mentioned it. I'm also taking. Okay, let me leave this up for the meantime. T place, top place. You get top place is that feature that will tell you that this component is supposed to be here. You get what I'm saying? You see, as I
Mm.
clicked it,
It left.
that image of your resistor, you understand,
Left.
it's
Yeah.
gone.
So
Yeah,
you don't even know what's there.
exactly.
Just in the R2, but nothing there to show that it's
Yeah,
existing.
exactly. So bottom place, I can also click bottom place. Also, this other resistor is gone. The top origin. So I was talking about origin of your component before. You get that place where you can click on so that you can perform some feature on such component. So that's what is referring to here, your top origin. Can you get me?
You say the origin of the component is a place where you do what?
Okay, where you can perform some certain feature like to move. If for example you want to move your component now, understand? You have to click on that origin before you can move that component. I said something about that earlier.
You talked about the cross in the middle. Is that the origin?
Exactly. That is what
Okay.
I'm referring to. Yes. So do you discover that when I click on this top origin, this cross at this battery, are you looking at this place where they wrote G1? This side,
Yes, yes, yes.
uh, this cross is going to go off. When I click on the top origin, this is gone.
Okay. Yes.
Thank you very much. Also, bottom origin, gone. So you might be seeing
Which
something
one
like
is
this.
bottom origin?
Thank you very much. So I think that is just for multi-layer board also.
Okay,
You get what
okay.
I'm saying? Yes, maybe there are some component at the top of your um, layer and some component at the bottom. So that's not part of the scope of today. So we're just dealing
Alright.
with a single layer board. So that's going to be off. What we basically need in this design is just our pads. And what is our pad? This green cycle-like feature you can see here.
Okay, that's the
These are
path.
your pads. Thank you very much. Then these are your traces. These blue lines that we
Yeah.
connected before. They are your traces. Those are
Addresses,
the
yes.
most important things. Other things, let's take them off so that they don't disrupt our production. So you can take
Okay.
off the top name, take off bottom name, take off top value, take off bottom value, and take off all these components. They are not even there, so you will not see them go. Since they are not present, you might not see anything leaving this one
Okay.
clicking. So this is teed up. You click it, it's done, and also done. So you discover that we're just left with our paths and our traces. The way you are done, just click on OK. Then we can just still move this our board so that we can minimize the size of the board we'll be using. So can you get what I'm saying?
Yes.
Okay. So now we might want to print. So we're actually done here. So we might want to just print, um, how will I even say, a copy of this so that we can use our printer to produce on a glossy paper. So what I will do is I will need this to be in black and white interface. So sorry, just give me a little, let me try and locate that aspect. Okay. So in your option here, when so in this your bar where you can see your file, edit, draw, view, tools, library option. Can you see my cursor?
Yes.
So you just go to your option menu. In your option menu, you see something called user interface. Are you
Mm,
getting it?
yes,
So
I
you
can
click
see.
on user interface. Now, the part we are in right now, is it schematic or the PCB layout?
PCB layout.
Thank you very much. So we'll just come to this layout option here. There is layout, there is schematics. So let us go to just the layout here. So here they say the background should be black. Okay, so let me just do this. I'm coming. So you can see our board. Then when we print, sorry, give me a little video when I'm coming. All right, okay. All right, so now we are going to print this board. Are you getting?
Mm,
Yeah, so what we just need to do is just come to this tab here where we get the print option at the side of your save. Can you see my cursor?
I'm seeing it.
So you just click on your print, you get the idea. So here you can see the preview of your board.
Yes.
Can you see the preview of your board at the right hand
Yes.
side of this view? Yeah. So at this point here, you can click on how you want your board to look like, either to be, but since we need it black, so we'll just click this here. Then there are also parts like the scale factor, where you can either increase the size of your board by two and the rest. You see how big it gets when I increase the scale factor.
Yes.
But we don't need that. If you increase the scale factor, the consequence is that when you want to produce the size of your your pads are going to be bigger
Very big
than the
than the
size
design.
of your components. Thank you very much. So what you need is just leave it as one, as if you are saying 1:1.
Mm,
Yes. Thank you very much. Then you can just print. Maybe you choose your printer from here. Here I'm using my Microsoft Word and PDF, print the PDF. So I'll click on it and I'll just specify the part I want to save that. Then name, save. So let me load this. So you can see this, right? You can
yes.
see this. Yes.
Yes.
So the consequence of this is when you want to produce in real life, you are going to be having a paper called your glossy paper.
A what?
Glossy paper. Gloss paper.
Glossy. Glossy.
Yeah.
Yeah.
Glossy paper. Yeah.
Okay.
I don't know if I can search it here. So your glossy paper is a paper in this form. It's not like your usual A4 paper. So
Okay.
this gives you a kind of surface that does not allow your ink to be absorbed by the paper. You get. So let me just
Okay.
give a very brief overview of how they perform the physical PCB production. So when you have this your schematic, your PCB view after designing it, so what you'll be
Mm,
needing is your I think your laser jet printer that makes use of toner. You'll be needing your glossy paper. So
okay.
what you do is you print this with the laser jet printer. So your laser jet printer makes use of toner, and that toner has a property that when exerted to heat, it kind of turns to a semi solid, a fluid that can actually a paste. Let me just say a paste like substance.
Okay.
So what happens is you will print on this gloss paper. Then when you print on it, when you want to perform and transfer to your board, you understand, you are going to be
Mm,
applying heat using iron. Yes. So that heat from the iron will make this your toner that you have printed on this gloss paper, you understand, to be in that paste like form, which which helps it to transfer from your paper to your copper board.
to be
Let me search
okay.
for something. There's something they call the copper clouded board. So this is exactly how your copper clouded board look like.
Okay.
So this place has a lot of has copper, you understand, in this layer. Okay.
All right.
So you are going to be printing your PCB at this top here. So you can just
Okay.
search YouTube on.
From the paper, you place it on the copper board,
Thank you very much. You place it on this copper board.
and
Then
then the
you are
paper
going to
has a
use
gum-like
iron.
stuff.
No, no, no. Before it turns to that gum-like stuff, that's the paste-like stuff. That's the toner.
Yes.
You have to
The
apply
to okay.
heat.
Okay.
Yes,
Okay. Okay.
exactly. So this face, this preview face, is going to be
Yes.
placed exactly on the face of this layer. You are going to
Okay.
place it on the layer. Then at the back of the paper, you are going to apply, you are going to use your iron at a certain pressure and at a particular period of time, and also your heat concentration. So when you have that, your toner is going to be transferred to this board.
Okay.
I'm coming. Good. So when you transfer your this thing, your pad on the board, it will be looking like something like this. Can you see this
Yes, I
structure?
can see.
This is exactly how it will be like if you have if you have a successful transfer from your paper to this your board.
To the board.
Yeah, then when you etch, there's a process called etching where you use acid. You understand? You put your this your board that has a transfer toner on it. You are going to place it into acid, and it will take off all this copper that have not been covered by these traces. All this copper remaining that have not been covered by these traces. So your end product is going to be something like this. Can you see what I'm showing you?
Yes.
This is going to be how your end product will be like.
Huh?
Yeah. So this little, I just gave you an overview of how the purpose of why we are even designing this in the first place. You can get it right.
Yeah.
Okay.
So when you place it, when you transfer to the copper board, what next do you now do?
Yes, as I said earlier, you are going to place inside acid. That's what you've transferred here. Okay,
Yes.
let me not use the word acid. Let me use the word etchant.
Okay.
So your etchant could be hydrogen um, H2SO4 or HCl. Yes,
Okay.
hydrochloric acid, where you can add something called something like a catalyst, hydrogen peroxide, H2O2,
Okay.
and add it to your HCl. So the mixture just gives you something like called an etchant. So that etchant, it reacts with copper. You understand? It dissolves the
Mm,
copper. Yes, and those parts that have not been, that were covered by the toner will not be tampered with. Yes. Do you understand what I'm saying?
mm.
Okay. Yeah.
So
So
at the
you
end
can
of the
just yes, you said?
no, continue, continue. Maybe at the end of
Yeah,
that, I'll
I'm
ask my
done.
question.
I'm done. I'm done. I'm done. I'm done.
So when you done transferring, you
Yeah.
now start connecting using the traces, or what do you now do?
No, 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 no. What I'm saying is you get this on your paper. This is your paper.
Yes.
Yes.
You print
Let's
on it.
imagine this is your let's imagine this is your glossy paper.
Yes.
So do you see we're having this toner of this type of pad and the rest. It's it's toner that you might be seeing here. I'm just giving you an assumption of things.
Yes.
So now this your paper, glossy paper with toner, you are going
Mm.
that's yes, this is something yeah, it's of this nature. When you print it out on glossy paper, this one will be having. I don't know if it's clear at your end. Let me try and check another part.
Like I've seen it. Yeah.
Uh-huh. Can you see it? You can see it, right?
Yes.
Okay, you'll be having something like this. You get.
Mm.
So this part now, you are now going to be putting it on
On a
this your
board
copper cladded board. Yes. You place this side exactly on top of your copper
on
cladded
top.
board. Yeah, you get.
Yes.
So then you use iron, your pressing iron. You get.
Okay.
So your pressing iron will give sufficient heat. Okay. Sorry, I don't know. They just took light in our PC. Let me switch to the other side. Are you seeing my screen?
I'm seeing your screen.
Okay. So you'll be able to transfer transfer this your traces to this complicated board.
Your cursor is not moving again.
It's not moving. Okay, sorry, please. I'm coming. Let me just stop sharing for a little bit.
Alright.
I'll share again.
Hello.
Hello,
Yeah,
I'm here.
I'm
I able.
coming.
Okay.
Okay, can you see my screen?
Yes.
Okay, you can see my cursor now.
Yes, I can see it now.
Okay, yeah. So these traces now that are on this glossy paper, you
Mm.
understand? You just put this layer on this board surface, this copper cladded board surface.
Yes.
Then you use your pressing iron to apply it at the plain back of the paper.
Yeah, the plain back, yes,
So that you'll be able to transfer these traces on this board.
on the board. Okay.
And yeah, and if that process is successful, you'll be having something of this form. I'm coming.
Oh,
If that process is successful, this is what you're
mm,
having something like this. That's the process of your
okay.
transfer. If it's successful,
Yes,
you're having
it
something
will be
like this.
something like this. Okay.
Yes, correct. So now you have something called etchant. Now you can see
Essence.
this how will I even say, this brown like substance at the back of
Yes,
this
like
paper.
oil, conjured oil.
Thank you. That is the etchant there. So this etchant, I think this is iron sulfite. But sorry, I don't really know the chemical name for this.
Okay.
But it's an iron compound. It's a compound of
Mm.
iron you get. So
Ah,
you just, yeah, it reacts with this copper layer that have not been covered by this your traces.
Mm.
yes.
Yes. So when you react with the copper layer, it takes off those copper off, and you are left with the remaining traces that were not covered by this your toner.
Okay.
Then when you have that, you just use a sandpaper or a soft sponge to clean off the toner that are left on the top, and you'll be having something of this nature. I'm coming. I'm looking for something that I can use properly here. Okay, you'll be having something like this. This is the end product, what you'll be having. Do you get me?
Yeah.
You can get me now. All right. So that's just the essence of all the process we've gone through.
Okay.
Yeah.
Um.
The section. I think I'm done. Yeah.
Oluchi, do you have any other question?
Yeah, and my question is, by the time you're done getting to this level, now this is the you're designing a board.
Yeah.
Then I think after you're
What
trying
do
to
you
continue.
what do you now do after now? Like you're done.
Okay. The next process you'll be moving to is you want to
Yeah.
drill. You want to drill all these pads. Okay. Should I use this for explanation or our main design?
Let's continue with this.
Okay, so let's say for instance, this is our board we have created. So there is
Yes.
a drill we'll use with tiny bits that will enable us to penetrate these points here where our components can pass through the board. Because our main components will be sitting at the other layer, at the other.
Under.
If you flip this upside down, yes,
Yes.
your component will pass through from the back. Then it is the how will I even say, can I use the word legs? Let me just use the leg
Yes.
or
Yes. So
terminals. The terminals of
the legs, the terminals come to this side, while the component sits
yes,
at the other
at
side
the
of it.
back, at the other side. Yeah. So yeah, yeah, you get the idea. So all these holes here, all these your pads here, you just drill them with your
And then
drill
connect from
bits.
the other side.
Yeah, you just drill them. Then when you are done with the whole drilling, you will now start your connection. Yes. So you'll be having a component like this. This
Like
is not our
this.
component. I'm just
No,
browsing.
I don't understand.
If you can relate with what I'm saying, you'll be
So at the
having
end of the day,
something
have
of this
something
form.
like this. Oh wow. So this is
Something
how
like
it's been
this.
done.
That's just it. Yeah.
Wow, that's nice.
Yes.
Mhm. So
Yeah.
Okay.
Babajide, thank you very much for the time and everything like that. So